And it's a special occasion for me. This is only the second time I've presented at GDC, and only the first time I've presented something of, dealing with my own work. So I'm wearing my oldest T-shirt. This is from the Hackers Conference. It's actually 2 years after I finished writing Pinball Construction Set. Don't worry, I washed it. So Pinball Construction Set has been a very rewarding program for me, obviously. I had a lot of fun writing it and seeing it come together. I mean, the idea and then actually making it real and making it work was very exciting. Programming is fun. And then Electronic Arts did a great job of commercializing it, and so I became kind of famous in the 80s. Almost a rock star royalty stream from Pinball Construction Set, and that let me be an independent game developer for many years, which I think is the best job title there is, really. And then afterwards, something unusual that I never expected happened, which is that people would, during the years after, the people would come up to me and say, "Oh, I played your games and I really liked them." Or even, Pinball Construction Set inspired me to become a game developer. And that's why I'm, in the software industry. And it's amazing how often I get that. So I was like, that name sounds familiar. I looked it up. Vint Cerf, co-inventor of the Internet. What? It's been very rewarding for me that way. And almost the best thing, really. So when the Game Developer Conference invited me a couple of months ago to give this talk, my first reaction is, no, it's a lot of work. I don't want to do that. But then I thought, this is a really good thing to do. We all should say yes more often, I think. Definitely, that applies to me. So I did say yes. And then afterwards, I thought, uh-oh, what am I going to talk about for an hour? I wrote that program 30 years ago. I don't have any of the materials. I hardly remember it, really. I remember some vague things. I could give a 5-minute talk. And I threw out my notebooks. I didn't even have a copy of the source code. So I was kind of panicking a little bit and thinking, well, I'm going to have to pad this out. And then I thought, I'll contact Electronic Arts. Maybe somebody kept a copy. And it turns out Electronic Arts has a vast archive of everything they've ever published, and including the very first titles. So it took some doing. They said, oh, I think we have it, but they could never find it. And I kind of bugged them a few times, and then finally somebody dug up the original discs that I actually made and as part of my deliverables, and I think they look great. They were readable, although you had to they have special hardware to pull the data off, and the data is very strange. The source files are in a kind of Apple text, which I completely forgot, but it's not ASCII. But they were nice enough to pull off the source and give me some nice .s files that I could read on my computer, and actually was excited to look, what would it be like to see this code that I haven't seen in 30 years? If you're a programmer, after like a year, sometimes you'll be looking at code and saying, who wrote this? And then all of a sudden you realize, oh, wait, I wrote it. And so I was very curious to see what would the source code look like to me. Would I recognize it? Would it be terrible? Which actually would be kind of good, because that would mean I've gotten better, But on the other hand, what if it was like really complicated and just brilliant? That would mean, well. So having the source code actually allowed me to go in and kind of check my memory and just kind of discover new things about it. So that kind of naturally led me to divide my talk into two parts. One is like the talk I would have given without the source, and then what I found there and what I thought was interesting and sharing. It's not going to be like tons of code here, so don't worry if you're not a programmer. Hopefully it'll still be interesting. So I don't know, maybe everybody here has played Pinball Construction Set. I'm not sure, but I thought it would be good to start off with just a little sample of what it was. DOS sort of software. And so I'll just play that. A very simple sort of real-world idea. It's a construction set. You have something that you're building on this side of the screen and a set of parts over here. And I have a hand here that I control with the joystick, and I use that to move things around, say, on the board, the game I'm building. I can modify this game. And I can get parts out of the box, and I can just add them over.
So they're kind of bumpers you're putting into your game?
I'm just putting bumpers, yeah. This is a favorite of really young kids. They like to just grab a whole bunch of bumpers, fill the board up with them, and put a ball on there. A pinball aficionado would gasp, but little kids don't really build pinball machines. They just sort of build things with this. And I can get a ball and put that over here. Then if I want to try out the game, I can just push this menu selection right here, and the game starts to play. Now, you can see I've got two balls, one up there. I can launch this one, and I can go out and play the game a little bit. And the balls drop down at the bottom eventually. But before I let that happen, I'll just go back to the parts box and start editing again. Get rid of some of these. I was tempted to play more. It's just really fun for me to watch. I was really excited to find this because up until then, I had actually just found these awful video grabs. There aren't many. They're really rare, and they were really glitchy, and I figured that was because they either were cracked or they were running in an emulator that had some bugs in it. So to find it and see how crisp the animation was made me feel much better. So the next two slides that I have are actually those crappy videos. But then last night I was just playing around. I thought, well, there must be an emulator somewhere. And so I actually found one, and I'm going to try to escape out of this and play that emulator. And I'd like to take this moment to thank the cat. Because thanks to the cat, I can actually show you my program. Whatever, her hard work led to our being able to do this. All right, now I need to switch to joystick. One thing that, is this thing paired? You can actually play it with a mouse. You can see on the right-hand side that you have a parts kit. And on the left-hand side, you have a boundary, an empty board. And the board was, the polygon on the board could be edited, so there was a polygon editor in here. And you could drag pieces from the board and drop them in. I'm not going to monkey around with it. Maybe I'll show you the demos that the videos that I have. So this is a little grab. I think it's the Commodore 64. It shows you some of the world editors. There's like some sliders that I wrote. And this is the Magnifier, where you can drag a little magnifier around on the screen and edit pixel by pixel. And this is an IBM version. And it shows somebody actually dragging some pieces. And then, so I'm going to just skip it. I'm sorry that the little demo didn't work. It's actually very difficult to control with the joystick, but it's kind of interesting. This shows you the little polygon editing. I'm not exactly sure what's wrong with that polygon, though. So anyways, it's not really well known, maybe, but this is not the first pinball game or even the second pinball game that I wrote. I wrote 3 pinball games, and this is the first one I wrote. I had been sort of playing around with making Pong clones, and I actually figured out a way to draw some walls and make it look kind of like pinball. But it was really slow. When the flippers were flipping, the little ball would sort of lag. And I didn't know how to bounce off of surfaces that weren't vertical or horizontal. I was just kind of learning all this math. And the story begins a little bit before I started on that first pinball game, when I was a grad student at the University of California. The computer in the middle there is a controlled data 6400. It's a mainframe, and we actually never saw that view. I just love this picture, though, with those round portholes. That's not how it worked out. And I took a class on supercomputer architecture, and the reigning supercomputer, and I think it would be outclassed like by an iPhone today. And I met a guy in that class named Andy Hertzfeld, and he had an Apple II. So that kind of got me excited. Even when I was in high school, I wanted a personal computer, but they were way too expensive. And I thought about building one, but I didn't really know anything about electronics. And I saw Andy's computer, and that really, kind of got me thinking I could get one. Berkeley had microcomputers, but they were that kind of like that workstation in the bottom right. It was really kind of a boring thing. It had 8-inch floppy disks and some funky operating system. And I took a class where we were assigned a project to write a Julian calendar. And I just never got anywhere with that computer. I never even was able to write like a multiply subroutine. It had a 6800, I think, in it. So it's just kind of interesting to me that the accessibility of a computer and what kind of turns you on to do stuff. So I really wanted an Apple II. And in 1979, it actually was not trivial to buy one. You had to sort of find a store that really had them. I found a store that kind of had them, and they said they could get it for me. And I actually had to wait 3 months. And in the meantime, I sort of looked at these other computers, the CompuColor and Radio Shack TRS-80. I almost got the Radio Shack. It was a lot cheaper. But I think I made the right decision to wait. I think things would have turned out much differently. The computer, my Apple II, I think was over $2,000. I didn't get a disk, just the Apple, and I immediately bought the RAM upgrade. And I didn't have $2,000, so I borrowed money from my parents, and who were very supportive. And it turned out that was probably the best thing I ever bought in my life. And it was just a beautiful machine. I think it's fair to say I loved that machine. I loved that computer. It's interesting to me to think that computers now are maybe 1 million times better, almost in every measure. So what an amazing time to be working in game development. And the Apple came with this technical reference manual. It was amazingly technical. The sort of entry-level stuff was how to use BASIC and program. And there was this absolutely charming handwritten documentation on high-res routines, the shape tables. Envisioned people writing their own high-res rendering software. They just provided firmware in the ROMs to do shape rendering. And it was a funny scheme with vector encoded images rather than bitmaps that we would expect today. For fun, I would type in this breakout game that came in the manual. There wasn't a copy anywhere. And I had a cassette recorder. That was sort of the way, if you didn't have a disk, that you could load and save programs. But I didn't have that. So I just typed it in every time I wanted to play. And I guess I would leave it on for a long time. And it didn't take that long, maybe half an hour, and you're just being very careful not to have any typos. And it was a really fun breakout game. I played it a lot. And I got pretty good at it. In fact, I got so good at it that I started making up artificial goals like, can I clear the board with the minimum number of hits, angle the ball in, and have it by itself clear out the rest as it bounces in the back. So when I finally, even that wasn't challenging, I decided I needed to start to maybe change the program and make it more interesting. And that's kind of how I got to be a game programmer. I first just started modifying the BASIC, and that was very difficult to really make it a different game out of it. So then I thought, I'll make an assembly language version of this low-res pinball. And I got a ball bouncing. It's just being undersampled. So then I started playing with making a high-res version of a pinball, of a Pong game. And so I started learning the 6502. And this is the programming model of a 6502, in case you haven't ever programmed this chip. It's a tiny chip, really. 3 8-bit register. You don't really have access to that directly. An 8-bit stack pointer, which is, I think, kind of interesting. It turns out that 256 bytes was enough for like almost all the Apple II programs as far as stack depth. And just comparing that to a modern processor, this is x86-64, the programmer's model of the registers that are available. The diagram isn't really fair because some of those wide registers on the x86 are 128 bits. So to scale, this is what it really looks like. Just a tiny little processor chip. And this is the Apple II's memory map. There were 64K of RAM. That's like the size of an icon nowadays. I'll just really go over them quickly. There's the 0 page. It's the first 256 bytes, and that's where the processor can access things slightly more efficiently than the rest of the memory. So you tend to like store your local variables and parameters there. And there's I think I have a mistake on my slide, actually. There are like low-res graphics displays and the text displays. And then what I was interested in was the 2 high-res graphics displays. Those were each 8K. Input and output, it was starting at that address. That's where you would, there were a bunch of magical locations to put the Apple II into different graphics modes to control the graphics, or to read the keyboard, or read the paddles. And then at the very bottom was the system ROM, and that actually had a bunch of useful stuff. Woz packed a whole bunch of interesting things in there, and everybody, I think, we talk to Apple II programmers nowadays, and they still remember some of the addresses. Like FCA8 was where you would call to delay, introduce a delay. And FB1E would be reading the paddles. So everyone's got different ones that they remember. A Pong game, and I tried all different kinds of experiments. I tried using the shape tables that Woz had built in, and I made a ball that was like 5 by 5 pixels, and I got the program working, and I ran it. So it was like not really going to work. So I decided I had to figure out like how high-res worked. And the Apple II, Woz was a very, very clever sort of generalist. He knew hardware and software. And so he knew that he could save a few chips on the hardware, correct for that in the software. And absolutely the right decision. The Apple II was expensive when I bought it. So whatever he could do to cost reduce it. And there was a similar thing on each scan line. The bytes sort of alternated because there was this crazy scheme to get a couple of extra colors. He used the top bit of each byte to sort of switch the color set. And so you kind of got 6 colors. But it was very difficult. If you wanted to plot like a pixel of a certain color, it was non-trivial to figure out which bits to turn on. And just as a little bit of a thought experiment to motivate like why Apple II software was designed the way it was, if you wanted to just do something simple like clear the screen, it's possible to imagine a theoretically fastest screen clear. It's simply a whole bunch of store instructions. They were 4 clocks each. Wow, 30 frames per second. But that's just clearing the screen, of course. If you need to draw something, well, that would be probably at least as much. So now you're down to 15 frames a second. And so that would really be kind of borderline, and it's very doubtful that you could actually make your drawing as fast as the screen clear. You certainly wouldn't want to touch every byte. 10 or 12 maybe if you really had very simple drawing. That's just not how I did my games, because you can actually do much better by not doing a screen clear, but just incrementally changing the screen. And so my first games just worked that way. There wasn't much on the screen, and when I wanted to move something, I would actually just change the bits that I didn't want and add the bits that I did want. Then you don't have to actually flip the screen. And you can get very high frame rates that way, effective frame rates, like in the hundreds. So here's a little example of that. This is like I made a Pong game, and I thought, well, I can't just make Pong. So I made all these variations, and I packaged them all together. And it was called Penny Arcade. I'll talk about it in a second. This just describes like how you move the ball. This is a 4 by 4 pixel ball. That's, I think, the size I used in my Pong games. And this is like, if you wanted to move the ball down, you would just erase the top row and then draw the bottom row, and it, would look like this. And I used that, point by point I would plot. And I was able to use that to build these Pong games and put them together into a package. I tried selling them. People would say, oh, that's great. You should try to sell it. And nobody, I would go and they'd say, oh, yeah, we'll sell it. But nobody had any money. And so I was kind of stuck, wondering what to do with them. And then my friend Andy, who had by this time started working at Apple, suggested I go down there and see if they would buy them. And I think really they were interested. When I showed up, they said, would you want to work here? And I said, no, I don't want to write games. And it was a funny place. There was a guy sitting at a desk in the entry. And it turned out he was the VP of software development, and there were piles of papers and empty cubicles. Everyone was rushing around. I think they had just moved in. And I said, well, do you want to buy my games? And he said, no, we're not really set up to buy anything. I'll tell you what, we'll trade this printer for your games. And it was a really expensive printer. I mean, for me as a grad student, I think it was a $700 printer. It was loud. It was very impressive. And so I took it, I jumped at it, really, and I was excited to get it. And so my grad student brain was starting to think, ooh, $700 I can write a game every week. I can make a lot of money this way. So it didn't really work out exactly like that. I did take this pinball game, the Pong games, and I made a pinball variation. So that's my first pinball game. And it was called Pinball. And it turns out that you could take a couple of games. There were two other games I had made. I was still using my point plotting routine. So all my games of this period are mostly black with little dots. And I made a game called Night Driver and a little Space Wars game. I think I drew the spaceship just dot by dot. I didn't know how to draw lines then. And I put it all together on a disk. And then I met this guy, and he said, I think I could sell those. His name was Al Remmers, and he had this company. And what he was like a store jobber. He would go and sell floppy disks, and he knew all the stores. There were lots of little stores. And so he went and came back like a month later. I suppose he didn't even have to come back, but he came back and gave me a check for $7,000. And I actually had a pirated copy, too. It was really hard to buy software. And this sort of opened my eyes. Wow, this had these little space invaders, and they were moving across the screen pretty fast. And there was a lot of stuff moving on the screen, and I thought, there's no way they're doing a point plot. They must be doing something else, but what? My friend Andy was telling me all these stories about how wonderful Apple was. And so finally I decided to go work there. I was hired on to work on the Apple III at first. And it was just an amazing scene. There were so many interesting people there. There were, Woz obviously was there. And he actually had a cubicle, and he was just engineering. He was starting to get pulled off into more and more things. Like, he was rich now, and he was doing his US Festival stuff. But he would still show up and go have lunch and have these crazy ideas when he would make bets with other engineers that, I can copy a floppy disk, with an iron. And people would bet, no, you can't. And he would just go off, and people were worried. There was a group of engineers there working on the Apple III on the OS and Pro-DOS. And they were totally obsessed with pinball. And they would, be excited about having a game developer there and trying to encourage me to make a pinball game. So there was a lot of interesting stuff going around me. Everybody there was passionate about Apple II and writing assembly language. And I think I just kind of went into hyperdrive as far as my learning, as opposed to working on my own. These are the computers that I worked on. I started out in the Apple III group, and that was kind of big software thing. They were making a graphics driver, so it was a little boring. But I could do the assembly language for it. And later on, I switched and worked on the Lisa group, and that was kind of amazing. I had heard about the Xerox user interface, but it didn't really make a big impression on me. I didn't realize how great it was. And not everybody did. But Steve Jobs and the rest of Apple, were pretty blown away by it, and they were hard at work on the Lisa. So I saw a lot of stuff with modern user interface, and absolutely that had a huge impact on me. So just going back to these engineers at Apple, they were obsessed. It was a kind of a fad, and every day at lunch we'd go and play pinball. And there was an arcade, and I've never been a good pinball player. I can only play my own games. And so I'm going to just show you a little movie of Raster Blaster in case you haven't seen it. This is probably another capture. So this is an attract mode that I made. I was really, really excited when I got that working. I know some of it was just built in. It was glitchy. Like there, the ball went through a flipper underneath. Flippers were hard. This was inspired by a game called Firepower. And we actually went. I had forgotten this, but my friend Andy just recently reminded me. He said, I remember you going there with a big piece of tracing paper and copying the layout of the board, pinball machine. I completely forgot that. So I'm a little bit at a loss to explain how I got so much better from that first pinball game to this. I was at Apple. I just have to chalk it up to the fact that I was around a bunch of really smart people, and they were giving me ideas and kind of accelerating my learning, because it's about a year between those games and this one. And when I was working on it, I was very direct. I actually built the board by hand, and I would sort of slowly work my way around. My friend Andy came by at my cubicle late one night when I was working, and he said, he didn't understand what I was doing. It just seemed crazy. And then finally enough was done where you could actually have the ball bouncing off of it and playing, and then people could see it. And there was a lot of excitement, to complete it. So, Pinball Construction Set, Raster Blaster rather, had interesting collision detection scheme. It had a database. People sometimes assume, oh, did you do the collision detection by reading the screen? My first games did, but this one didn't. It had a database in memory that it used to very quickly look up for every scan line, what are the things on the board at certain positions, and what are the angles of the edges, and information about how to bounce. And there were for every thing on the screen, its x coordinate and its angle. And so visually, that looks like this. So just looking at this system now, it makes me think, God, it's like the space shuttle. It's got all these thermal tiles, and they've got to all work perfectly. And if anyone doesn't, it's catastrophic. People sometimes say, you owe me a night of sleep because I played Raster Blaster all night. Well, I lost many nights of sleep trying to keep the ball inside the board on Raster Blaster. If you look at that red vector, it's kind of almost parallel to that little tile thing there. And if it just goes up to the next pixel, it's going to be behind the other tile. So I had a lot of leaks like this, and pinball is almost a worst case because the ball hugs the wall. It wants to stay. And so things in contact are sort of tricky for collision detection, especially on 8-bit microcomputers. So math was very low precision. So I'd like to say that I went in and re-engineered my design and came up with a better algorithm, but no. I actually just started tweaking the values by hand. This was a gigantic table in the source code. I would just tweak values and play and tweak and play. And the changes would kind of cascade sometimes. Well, if I move that, then I have to move this. And it was very laborious. But in the end, I got it to work well enough. Another thing that I remember from back then is just how much time I spent on bit twiddling. I did all the art for these games myself. And I played around a lot with the different balls. And you can draw balls on graph paper and try to make them look good, but you really have to see them on the screen. And it turns out that a ball that's 4x4, it's really hard to make it look good. And 6x6 is kind of paradoxically also kind of tough to make it look like it's not either square or diamond-shaped. But the 5x5 ball is a really nice-looking one. It was about the right size to get a full table. So that's why all my pinball games have a 5x5 pixel ball. And this is one of them. I watched Will Wright's presentation from a previous GDC. He described how Raid on Bungling Bay was built with a little tool he made. And that tool evolved into SimCity. And so this is the same story, really. I did a lot of bitmap editing, and inspired by what I'd seen at Apple with the Lisa, they had a little magnifier app. I built a magnifier to make Raster Blaster art. And you can sort of see the shameless ripping off of the Apple logo there, and the Billy logo that was also kind of a play on Bally. And they actually asked me to stop, but that was years after I had stopped. It was very laborious, though. There was no cut and paste. It was just pixel by pixel. And so I think I wanted the Billy logo over 8 pixels, but it was just too much work. So that's the way it turned out. And anyways, this little program actually is the seed that Pinball Construction Set grew out of. This is the first part. And the magnifier is pretty much the same. You little paint things down there, and the little, does it say quit? It's hard to read, yeah. Yeah, that actually is almost unchanged in Pinball Construction Set, and everything else grew out of that. So also, I had all these toys when I was a kid. Fisher Technic is like lesser known than the others pieces, sets. This one was the basic set I had, and it was very expensive, and the expansion sets were completely out of the question for a kid. But they were the inspiration for Pinball Construction Set, definitely. This is, in fact, the packaging when Budge published it at first. You can clearly see I have the same primary colors. It was meant to be a toy. And I think also, after I had done Raster Blaster, I didn't really want to write another video game. I wanted to do something that was different, more like a toy. And I think that it goes back to all these things that I played with. They were my favorite toys. So this is another little image I discovered in my box of slides. This is my setup, I guess, like in 1984. It's got my Apple II. I have a monitor to actually work on. I had a color TV hooked up out of the picture. And you can see my Cinertech assembly language manual. For my very first games, I actually worked off of a little card that I pretty much wore out. I think that still have that. And so when I found this manual, because I was always like obsessed with the instruction set of the 6502, is there some secret thing I didn't think of to shave a cycle off here? And always looking for some like opportunity to do some trick. And there's kind of an interesting computer right off to the corner there. This was just after I had left Apple. I only worked there for a year and a half. It's not obvious. Maybe this view will give you a better idea of what it is. It's a prototype Macintosh. I had one of the first, maybe like a dozen of these that they made, and sadly they made me give it back after the real Macintoshes arrived. I think it would be worth a lot of money. It's a museum piece. It had an Apple II floppy drive in it, and it ran the UCSD-P system, but it had a 68,000, and you could actually write software for it. And I don't know if it's well known or not, but I did actually write a Pinball Construction Set for the Macintosh. So now let's look at what was inside those disks. It's a little bit like that Geraldo Rivera show where they open up the vault of Al Capone, and what will we find? Looked at these, and I've uploaded them. They're on the web on GitHub. And I'm making annotations to them. I'm adding comments because there really weren't very many comments. And I'll upload those. But there were like 6 source files that were interesting. The program was broken up because it wouldn't fit in the memory of the Apple II with the editor I had. I didn't have an editor that could read off the disk and sort of stream stuff. So the program is broken up into pieces. And I'd say it's about like 20,000 lines of assembly. And a lot of it is just data. And I was able to piece together over the Apple II sort of memory map all the things that I used the memory for. So one thing I did remember and I confirmed is I had a lot of tables. The key to Apple II programming, to making things go fast, was to just not compute anything and just pre-store, pre-calculate stuff. So there was like 2 really huge tables with bytes shifted by various amounts. That was an important optimization. The pinball game is kind of in the middle there. I didn't use the second high-res screen. Only one high-res screen was used. So in the middle, there's like the actual list of pieces and data. They were variable size because some of them were polygons with n vertices. I think you could have 64 verts. And then after that was a table where everything was scanned out for collision detection and gameplay. And then the rest of the game is sort of in a big blob. And I think there were overlays for the editors because when I played in the emulator, you can actually see like a delay when it goes from one kind of editor to another. But the rest of it, you could play immediately in the immediate mode. So there was a lot of stuff that was resident. The program really isn't big. I didn't have to like scrounge for bytes, the stories that you hear of VisiCalc, where they're just looking for every little bit they can find and packing things. That never really was a problem. So this slide shows the game, how the game data was divided up. So just interesting things to me were like low and high. Those are kind of odd names for a table. They're really bad, and they're very short. And I didn't even change it. I just kind of copied the code in and left it that way. It was just like, the DNA that we have that's from reptiles. And then the other thing I noticed was that I made a mistake, and that this table straddles a page boundary, which was like bad to do on a 6502, because when the index register, I just never saw it. And because there were no other eyes to look at this software, that's you know, just the way it was. And I guess I took that penalty a lot, and the game's still okay. So it can't be perfect. Like the run2.s, 8554, just the manual nature of putting together this program sort of struck me. And here's another example. Essentially, I was hand-linking this thing because it had to be built in pieces. Amazingly tedious, and just a reality of like software development on the Apple II. When you're programming in assembly language, it was important to keep stuff here. If you're indirecting through a pointer, for instance, you would have to have the pointer on the 0 page. And so it's very manual, sort of, okay, this software will use this part. You didn't want to like call a function and have it overwrite stuff that you were using somewhere else. So you had to be very careful. And another thing is just how much handmade asset code there was in there. This is all the flipper frames. There's a vector of like how hard the flipper should kick the ball, depending on how far out it is. You know, obviously when it hits the tip, it should really fling it, you know, harder, and then maybe at the very tip, not, you know, just kind of nub it a little bit. And then the other rows, I think, are collision data. So they're collision data for each frame, because the flipper is moving, and you want to have it's basically a different shape to see. I divided it up into pieces. Well, you know, it's kind of subjective, but this is, you know, for this, and this is for that. I took one category off, parts data. That was just enormous compared to the rest, so I took that out. So this is really what I was involved in coding up Pinball Construction Set. Probably the biggest item is polygon drawing, and that was maybe the part I would be most proud of, except for the simulation. So polygons are, you know, essentially these, and it turns out to be really hard to prevent people from making crazy stuff, so I just let people make crazy stuff. You can have a polygon, you're just dragging points, and you could do all kinds of interpenetrating polygons. I had to come up with an algorithm to sort of deal with those kind of polygons, though. Edge representation into pixels on the screen. Today, I would Google it, but in that time, I had to find a book, and I used to love to haunt computer bookstores and find good books. This is a picture of the cover of Newman and Sproul. It actually had a cover with a pretty color picture on it, and it had algorithms in it, and I kind of collected these. The algorithm that I used is called, and it basically means just sorting all of the points and finding points that have two downward edges. Those are sort of starts. You have to worry about horizontal edges. It's kind of a special case. And then just working your way down those edges until maybe one of them stops, and then merging them together. It's got things like sorting. It just does bubble sorts, because there weren't really a lot of different things in the list that had to be sorted. And I think another tricky thing about it was just to do the walking down the edges, you have to do a divide. And division is really, really slow on an Apple II. I had some fast division code. You think about like multiplication too, to multiply by 8, and then you subtract 1. There's no multiply table. I just didn't multiply at all. Multiply would take, like a 16 by 16 multiply, I just recently calculated, would take about 1,000 cycles. So you could do 1,000 a second multiplies and nothing else. So that's like 30 a frame maybe. Just really not enough to do anything. So there's no multiplication. The division, there was no way around that. So this is one cool little bit I took out. This is bitmap drawing. It's pretty important to draw the ball, to draw all of the shapes on the screen. This routine was critical, and this is the inner loop, where it uses those shift tables to, and the code actually is self-modifying. I poke in the addresses of the actual table that's going to be used to get the shifted amount. And so it's about as fast as you could do bitmap drawing in general. Here's another cool little bit I took out. This is the magnifier. This is also like heavily self-modified, and it turns out you just store the address of store the address of where you're rendering here, and then you can blast out a pixel. The magnifier was kind of tricky because it's a pretty big area of the screen, and like I said, it's very difficult for the Apple II to move big areas of the screen fast. So it was fast enough, and these are the parts that are really fun because they're tiny little bits of code. There's actually, I think of them as kind of the easy parts, and I'll talk a little bit about that in a second. So this is the raster blaster collision scheme. I knew that this wasn't going to work. This was kind of the second biggest problem. I couldn't go visit all of the people who bought Pinball Construction Set and patch their leaks. So I had to make a scheme that was much more solid. And what I did was I just changed from having these sort of edge X's with a slope to having the idea of a span. And the span sort of allowed me to have the idea of whether it was inside or outside. And so the span has 2 points, the left and the right, and 2 slopes. There were only 32 different possible angles, so it was still kind of that quantized, the quantized rotation, but it was convincing enough. And then, of course, I think every video game has the little bit of cheat code where you have to oh, the ball's off the screen, bounce it back. So there, I did find that little bit. But the reality really of all this is that there was just lots of code like this, just page after page. And I finally had to give up trying to understand it. I may slowly, add more comments over time, but I've sort of, it's a sort of hit the wall on this. This carry bit is set, so I can do a BCS, and that's a jump. All sorts of tricks like that. Or, oh, the Y register has 255 in it, so I can do this, and I don't have to add and change anything. And, of course, there were no comments, really. I think there are very few comments, if any, on this page. This is the code to move the ball and check whether it's hitting something. I'm proud of the fact that, it worked, and it was fairly solid, and you could build pinball games. I think the collision detection actually is better in Pinball Construction Set than in Raster Blaster. The one that I used to write Raster Blaster and Pinball Construction Set, it's in a museum. And I was very surprised and delighted and flattered to see that I was called Bill Budge, the people's programmer. But it's there, and actually they're taking good care of it. It was just sitting in my garage doing nothing. But anyways, something that I think is a wonderful thing, and more people should have that experience. This is not very well known. And I was really pleased with it, actually. It's for the Sega Genesis. So I had a 68,000. I recoded the whole program. Obviously, the graphics are very different. It has a tiled graphics and sprite graphics system, so you can have very fast animation. The whole screen's moving. But on the other hand, you don't have total freedom to do whatever. So the little boundaries, a polygon scheme wouldn't work. But I think the physics is really good. The flippers work much better. Everything looks beautiful. I had an artist. And it really worked very well, I thought. But it didn't do well commercially at all, and people didn't get it. It was like, well, it's like a collection of 20 pinball games, but they're not really very good, and it's just really weird. I don't get it. So it just kind of shows you that there's a time and a place, and there's luck involved in how well things will do. It had some a different kind of graphics. It had different tile sets. One was all body parts, and another one was very industrial. Making the program, took 6 months. Making the toolkit took a year and a half. It was just, oh well, this is, you can't just make it work. It has to be usable by other people. I didn't quite appreciate the difficulty of making a reusable library, and they really held me to it too. So. Tower of code, but it seemed to work. But it was kind of the end of the Apple II, really. So I think of this as maybe the pinnacle of just raw, plain old Apple II software. One interesting thing, which I don't think is known at all, is this program came out before the whole HIV thing. So the menu name was going to be AIDS, and it came out before this really became like kind of awkward. And Mac Paint had the same thing, but they were able to change it to goodies. So kind of interesting. So classic game postmortems, I guess they're kind of like regular postmortems too. I thought maybe I would put kind of the lessons I learned. So what went right? I think just continuous small improvement can get you to amazing places. I started just with very basic stuff. I think my code was pretty ordinary, improving, and it's amazing where you can get. So starting with like a small thing and then evolving it is very effective. It's a really good thing. So if you're working for small companies is great, but then working at a really great large company where lots of people can teach you is also a good thing. You may alternate in your career with those two things. I was kind of compelled to make a construction set rather than just another game, but I think it takes like a certain audacity to do stuff, so a little bit different. So kind of believe in yourself. And don't worry too much. I think it's probably really as hard to make an Angry Birds clone and make it successful as it is to do something totally different. There is this sort of ebb and flow. I think the early 80s were like the 60s for software development. Anything goes. People were really receptive to lots of different stuff. It's like, no, it's got to be this and that. So it's harder. But yeah, I would encourage people to try to do new things. I think, just optimizing code in crucial, places was, something that went really well. I was able to come up with some really good optimizations just because I just lived and breathed the 6502 assembly language and was constantly, just thinking about how to make things better because the tools were so bad and the development was so tedious. So then 5 things that went wrong. I kind of am astonished that I didn't write my own assembler. I mean, it just seems like so obvious. How many months did I suffer with this thing, and how did it kind of hold me back? I think it must have. And then the other thing is premature optimization. I hadn't heard the quote, premature optimization is the root of all evil, and sort of made it harder to change things. And then that kind of led into if the code was bad, I would try to just fix it until it worked. You can get away with that in video games to some extent. I worked in a vacuum. I think that I didn't get enough people looking at my code. At Google, we always do code reviews, and it's just amazing how many things a fresh set of eyes will see. And you just can't forget everything you know about the code. Look at it, and then see all the stuff that's wrong, and then, get your memory back so you can fix it. And I didn't comment my code. I think that's all I have. Are there any questions?
I'm wondering if you got any pushback pinball games, especially from EA. And I'm not being mean or evil because I did work there, but I just wonder if anybody said anything about that, if there was any thought why are you putting out this thing that will let people build infinitely versus, let's build a bunch of pinball games and just keep pumping them out?
So I knew Trip Hawkins, but I think, honestly, he was very much in favor. He loved the idea, and that's why he picked it as one of the first titles to do. They were, their mantra was simple, hot, and deep, and he definitely believed in Pinball Construction Set. Yeah, there was that, definitely. I remember it almost got canceled. Somebody said, why are we doing this? And from their point of view, right, if they're doing this title, then they can't do something else. And if that could sell 1 million copies, and this is kind of risky, why should we do that? And so there is that kind of thinking. My producer, Rich Hilleman, to his credit, he fought for me, and he said, well, this is an artist relationship, we want to do it. And so they published it, and I'm really glad. So that I can show it to you. And, some people there are people who played it and really liked it. But it just goes to show that, there are different times and different environments. I think now actually is a wonderful time for trying new things with the web, and there's mobile and app stores, so many ways to deliver a game today. you can do whatever you want. And I think it's really a great roll of the dice to do something crazy.
First, I want to thank you for making Pinball Construction Set. It's
You're welcome.
One of my first PC games I'd ever purchased, if not the first, and definitely the first game design, game development tool sort of thing that I ever worked with, and inspired me very much to work on games for the rest of my life. But anyway, my question was, I had the IBM PC version of the game, and I noticed that a lot of the things that you talked about here were Apple-specific, and I was wondering if you did the conversions for the for the IBM and the C64 and the other versions of it, or what extent you had to advise them, or if you coded them as well.
That's a good question. So I always had a knack for doing the wrong ports. The IBM PC and the Commodore were by far the most successful, and those are the ones I didn't do. The Macintosh. The Atari 800 was easy. I just had to hook up a serial cable, and they told me some interesting stuff. They said, well, did you know that you're drawing the ball twice? Which when I think about it, I'm not sure that that's right, because I think the ball had to move by 1 pixel every time. So maybe in a frame it could move over and then up. It couldn't move, I don't think it could move diagonally.
The original box art too, is that up there somewhere in the internet?
Yeah, there are pictures, there are images. I think I even have 1 copy left.
Nice.
Yeah, I used to have a whole box of them, and I kind of like, oh, I don't need all those. And then finally, now I'm down to 1. But yeah, thank you. There's a funny story about that. When I first started with EA, they hired a really great advertising team called Goodby, Berlin, and Silverstein. And I think it was Rich Silverstein had met with me, and I went to his office.
Our destination and got a lot of people inspired. I'm glad you mentioned the early years of playing with Tinker Toys and Legos being a fundamental contributor to your career. I recently got to meet Dr. Ivan Sutherland, considered the father of computer graphics. Created the GUI back in 1963 on an X2 mainframe. And he had a similar story. And so I wanted you to talk a little bit about coding in education, and is it our responsibility to kind of push for teaching code in schools as one of the 3 R's? Thank you.
I was very lucky that I had a teacher who she had been a systems analyst, and she decided to become a teacher, and she pitched this idea of a computer programming class. This was in 1970, maybe 1970. And there was no computer in the school. Nobody had a computer. And the principal said, sure. But I had no idea what to expect. I had I think my parents had bought me a little Digicomp, little plastic computer that had 3 bits, and we had to write programs on coding sheets, and it just seemed bizarre and very difficult. And then she did something really great. She did not teach us everything. She just said, write a program to multiply 2 numbers. And so I would just I remember waking up in the middle of the night, and it just came to me the way to do it with a loop. I just was incredibly excited, and I think from that moment on, I was going to be a computer programmer. So I think it's incredibly important to expose kids. And I think if you have an aptitude, now it's a little bit easier. You're not using autocoder, and I regret that she didn't, because I don't think you can really understand the world effectively today without understanding what code is and what can be done, what are the limits. So, yes, absolutely.
Yeah, there's a great program called Scratch that's object-oriented, node-based, and it teaches arrays and if-else statements and things like that. I highly recommend it.
Welcome.
Hi, Charlie DeMerchant from Semi-Accurate, and I did buy the 800 version way back when, and I found it about 6 months ago when I was cleaning my basement, and my wife asked me to throw it out.
I'm having a hard time hearing. Sorry.
I bought the 800 version, the Atari 800 version, and just found it about 6 months ago, and my wife asked me to throw it out, and I won that one. But my question is, can you go a little into the decision behind making your own physics engine versus licensing one for a Pinball Construction Set? Could you talk at all about sales and roughly what's sold and what platforms and in what amounts? I mean, if you don't want to say exact numbers.
I heard different numbers. I think it went platinum, but in those days that meant 250,000. I think maybe 300,000, something like that. Cool. Yeah, all the different versions. And virtual pinball, I know that was not very many. So, but it was later too. Maybe that was 50,000 or something.
Hi, my name's Darren Grant. I would say that this PCS was instrumental in one of my aha moments in elementary school. I got a hold of a copy of it and created a pinball table and sold it to my teacher. And that was about the end of that. But what I wanted to ask was...
I see a real thread of continuity. I'm very interested in editors. And I did a lot of work. Before Google, I was at Sony, and I did a lot of work on tools for building games. So I'm still fascinated with that and empowering. And I moved to Google because I'm very interested in the web platform, and that's my intention over time is to build some of the same kinds of game building tools. And even more generally, diagramming tools. There's some really great diagramming apps, but I think there are more things that can be done as part of the Chrome team, and I work on the plugin API. Everything I do is open source, so you can actually just search and see what I'm up to. A lot of it's kind of just plumbing things like being able to draw text from plugins. Sure, you're welcome.